Hello everyone. Today we are going to discuss about the practical number 3 trigonometric functions 1 from XII Science and Arts Mathematics Practical book published by the Maharashtra State Board for HSC. So let's go. The practical starts with few formula for principal solution. Principal solution always lies between 0 to 2 pi. Remember 2 pi is not inclusive. General solution for sin theta is equal to sin alpha, cos theta is equal to cos alpha, tan theta is equal to tan alpha, and the general solution for sin square theta is equal to sin square alpha, cos square theta is equal to cos square alpha, and tan square theta is equal to tan square alpha. Note this is same solution for all these three formula. Correct? Then we have sine rule, cosine rule, projection rule. All these we are going to use, and the half angle formula. So let's start with the practical now. The first sum is for prove that the sum can be done by using sine rule, cosine rule. This is given solve by using both the rules. Okay. Second sum, again prove that, and this is also given solve by using sine rule as well as cosine rule. You are using both the rules over here. Now the third sum. Third sum is given as a filling in the blanks. That means half sum is solved. Here we need to use the half angle formula, and as got half angle formula required, we use what? Tan half angle formula. So as we know, tan A by 2, tan B by 2 and tan C by 2 formula we already have. Tan A by 2 is square root of S minus B, S minus C divided by S into S minus A. So correspondingly, you have to write for tan B by 2. So if here you have numerator B and C, so here we'll have A and C. So what you'll have in the denominator, it will be similar to this S, and when for A by 2 it is A over here, then here obviously S into S minus B. Similar way, what will be in the numerator for tan C by 2? S minus B and S minus A. Yeah, so here's the formula. You can write down and fill in the blanks. You know what is 2S? 2S is A plus B plus C, and S is called as the semi-perimeter. Okay, done. So we start with the left hand side. Here we are going to use the reciprocal of tan A by 2, tan B by 2 and tan C by 2 formula. Okay, complete the formula, complete the blanks. We already written, just write the upside down. Okay, the reverse of tan A by 2, tan B by 2 and tan C by 2, reciprocal. So here's the answer if you need any help. Done. Now, how do we add these terms? One, square root is a problem. Second, the denominators are different. So what is our first thing? We'll make the denominators same. So we can see three type of terms, S minus A, S minus B and S minus C. So we'll try to make the denominator with all three terms. Okay, so what is missing over here? S minus A. So let's multiply and divide both the numerator and denominator by S minus A. Here similar thing, S minus B, and here S minus C. Okay, so first you completed the formula. Next step is like this, where you are adjusting the denominator to be same for all the three. So you are writing the missing terms over here. So as you have multiplied S minus A both in numerator and denominator, what will be here? S into S minus A square, because one was already there and you got one more, and we got one more in denominator. Similar things in second and third term. So as this is given, you can write similar for first and second terms, and if you can't get it, here's the solution. So complete the blanks. You can pause the video anytime and complete your sum. Great. Let's forward further. So here, what is common? The common denominator, and remember S was there for all the terms. So we'll take it common. Now what is left inside? Here we had S minus A the whole square, then S minus B the whole square and S minus C the whole square. So write down that. Now square root and square nullifies each other, and you are there with the terms s minus a. What comes here? S minus b and s minus c. Same, this is repeated. It will be as it is continued. And then you put s like terms added, that gives you 3s, and minus a minus b minus c put in the bracket. So this is filling the blanks for this term, and next is this. Clear? Okay. So what is a plus b plus c? As we had seen, it is 2s. Okay, the perimeter, and 3s minus 2s gives you s. Now what is left? Here we'll keep b and c together. S minus a will take other side. So here root of s minus a. As this becomes a formula, you'll require s minus a still to complete this formula. Which formula? The tan formula. Remember, we started with. Okay, so here we'll add s minus a and s minus a square. It will become. Okay, so square and square root gone. So s minus a comes out of the bracket. And what is left now? Finally, s is a plus b plus c, and this gives you b plus c minus a. Okay, and this is nothing but tan a by 2, the reciprocal formula. So it is cot a by 2. Done, as this is what required. Clear? Go to the next now. Fourth sum, it is given as 2x lies between 0 and 1, and sine inverse x plus sine inverse 2x is equal to pi by 3. Then find x. Okay, this is an trigonometric function equation we need to solve. So here, this is also a prompted solution. We have to complete this by completing the blanks. So we take sine inverse x as theta. So obviously sine theta will be what? X. And what will be cos theta? Cos theta is square root of 1 minus sine square theta. So that means 1 minus x square. So wherever cos theta will come across, we'll substitute what? 1 minus x square. Okay, so let's move further now. So here, this was what we have to start with. This we have replaced by theta. So sine inverse 2x will be pi by 3 minus sine inverse x, which is theta. So here what you have to complete? Sine inverse x. Okay, the blank is filled. Next. So 2x. So sine goes on the other side. It becomes sine of pi by 3 minus theta. Okay. Now, for right hand side, we use sine a minus b formula. What is it? Sine a cos b minus cos a sine b. So here a is pi by 3 and b is what? Theta. Now we know the value of sine pi by 3 and cos pi by 3. So obviously we are going to substitute over here. Okay, you remember the values, then substitute and filling the blanks. So sine pi by 3 is root 3 by 2. Cos pi by 3 is half. Now you will take 2 on the other side. It becomes 4x is equal to root 3 cos theta minus sine x. What next now? So we'll replace this theta by x, as we have to find out what? X. Right? So this is the next part. So here we have to complete. Cos theta will be replaced as what? I have already told you. It's 1 minus x square minus x. X is taken on this side. It becomes 5x. And common root for 3 into 1 minus x square. Multiply this and square the other side. So square both the sides actually. So that becomes 25x square is equal to 3 minus 3x square. Minus 3x square comes on the other side. It becomes how much? Write down that. And 3 remains over here. Okay, so that becomes 28x square is equal to 3. So obviously x will be square root of plus or minus square root of 3 by 28. And But what we are given, 2x lies between 0 and 1. So we have to take only the positive value. So x has to be square root of 3 by 28. So that complete this sum. Okay. Complete this and move further. The fifth sum is for general solution. We are given two sums in that. So we start with the first one. Sin theta plus cos theta plus 1 is equal to 0. Okay, we need to find what will be the general solution for theta. So we write this as sin theta plus cos theta is equal to minus 1. Now many times you go for solving by squaring and all, but that's not correct. Here we'll introduce 1 by root 2. Remember, 1 by root 2 is very good friend of us, and that can be conveniently taken as sin pi by 4 or cos pi by 4 as we require. That's why 1 by root 2. So when we multiply both the sides by 1 by root 2, we get sin theta into 1 by root 2 plus cos theta into 1 by root 2 is equal to minus 1 by root 2. Okay, now I'll try to make this as a sine formula and write this as sine of something, and or I can do this, convert this into cos formula and write this as cos of something. Okay, so I will prefer sine. So for sine formula, what is that? Sine A cos B plus cos A sine B. So sine theta is already there. This I'll write as cos pi by 4. Your cos theta is already there. I'll write this 1 by root 2 conveniently as this time as sine pi by 4. Remember, that's why I told you 1 by root 2 is very good friend. And this can be written as sine pi by 4. Okay, now using sine A plus B formula, this becomes sine theta plus pi by 4. And this is negative. So first negative value we get when we are in third quadrant. So we write this as pi plus pi by 4. Sin pi plus theta is minus sin theta. So now we have both the sides sine. So we can go for what? The general solution formula for sin x is equal to sin alpha. So this becomes your x will be equal to n pi plus minus 1 raised to n times your alpha, that is 5 pi by 4. According to this formula, correct? So we get this thing, taking pi by 4 on the other side, theta will be equal to n pi plus minus 1 raised to n, 5 pi by 4 minus pi by 4. So you can stop here saying n is belonging to z, or you can write two solutions when n is odd and when n is even. Correct? Next, we have to solve the b part. Tan cube theta minus 3 tan theta is equal to 0. Taking tan theta common, tan square theta minus 3 is equal to 0. So here we use the formula if a and to b is 0, either a is 0 or b is 0. So either tan theta is 0 or tan square theta minus 3 is 0. Now tan theta can be written as 0 and tan square theta written as root 3 square. So use the general solution formula for tan x is equal to tan alpha and tan square x is equal to tan square alpha. We write tan theta is equal to tan 0 and tan square theta is tan pi by 3 square. So using the formula we get theta is either n pi or theta is m pi plus or minus pi by 3. Use another letter than n, and remember, write both of them are belonging to z. That's a completion. Sum. Using cosine rule, prove the sine rule. So remember the formula. Cosine rule is this: cos A, cos B and cos C, and sine rule is this. Now how do we prove sine rule? Using cos rule. So we try to find out what is sine square by A square, sine square B by B square, and sine square C by C square. Sine square A easily can be written as 1 minus cos square A. So cos A, by using cosine formula, we replace it. Now how do we do this? We have to take the LCM, obviously. So that becomes 2bc square minus this the whole square, and 2bc comes down. 2bc square comes down, so that becomes 4a square b square c square. Now here we have difference of squares, so we'll use the formula x square minus y square is x plus y into x minus y. Using this formula we are getting this. Now open the brackets. inside bracket. So we get this terms, okay, and you can see this taking minus common, it becomes a full square of b plus c and a square here. Similar way, this is b plus c the whole square minus a square. Again, difference of square formula, we get 4 brackets, 2 brackets for first one, 2 brackets for second one. This is what we are getting for sine square a upon a square. Okay, let's try doing this for similar thing for sine square b by b square. Okay, to the previous thing, we are just replacing a by b, b by a. So in the cosine formula, you just replace a and b, you get this, and similar number of steps. And what we are getting is all same terms, right, on the right hand side. So obviously no need to prove the last one. We can write down that similarly we can prove that sine square c upon c square will be also same. So what we are getting is sine square a upon a square is same as sine square b upon b square is equal to sine square c upon c square, and hence the sine rule. So we proved the sine rule using cosine rule. Next one, the last one. Write the principal solution of tan phi theta minus is equal to minus 1. Remember, principal solution lies between 0 to 2 pi. Okay, let's consider the graphs. Okay, we'll compare the graphs of tan x and tan 5x. This is the graph of tan xy is equal to tan x when the period is pi. The period is pi for tan x. And this is the graph for tan 5x. What will be the period of this? Remember, that will be pi by 5. Okay, now look at the solution of tan x is equal to minus 1. We are going to solve this, right? Tan 5x is equal to minus 1. So when tan x is equal to minus 1, you can see there are only two solutions between 0 and 2 pi. Okay, but what happens when the graph becomes tan 5x? The graph gets condensed. Okay, and we are getting how many solutions? You can see 10 solution between 0 to 2 pi. So this is how the graph looks. Now we'll prove this or find the solution using mathematics. So we solve this mathematically now. Tan phi theta is equal to minus 1 can be written as minus tan pi by 4, and 10 is negative when it is in second quadrant. So that can be written as tan of pi minus pi by 4. Tan pi minus theta is minus tan theta. Now this becomes tan phi theta is equal to tan 3 pi by 4. So phi theta will be equal to what? N pi plus 3 pi by 4. And this is using the general formula, general solution formula for tan x is equal to tan alpha. Divide by 3. So you are getting theta is equal to n pi by 5 plus 3 pi by 20. Now this is general solution. We have to find what? Principal solution. So we substitute n is equal to 0, 1, 2, 3 on till we get the value of theta between 0 to 2 pi. Once it exceeds 2 pi, we stop. Okay. So first value n is equal to 0. That gets you 3 pi by 20. Then 1. That's 7 pi by 20. 11 pi by 20 when you get n is equal to 2 and so on. So here after this, if I add here, I substitute 10, what happens? 10 pi by 5 is already 2 pi. So that exceeds 2 pi. So we have to stop over here. We are getting this 5 and this 5. That's 10 solutions. Got this? Even we can use the full solution and get the solution directly without introducing general formula. So tan phi theta is tan 3 pi by 4. Phi theta is 3 pi by 4. So first solution is theta is equal to 3 pi by 20. Now remember the period is what? Pi by 5. So the function repeats itself after that period. That means we are going to get same solution if we go on adding pi by 5. So you add pi by 5 to this one, we get 7 pi by 20. You add pi by 5 to 7 pi by 20, you get next solution. So go on adding pi by 5 till your value theta is less than 2 pi. Okay. So that's how here also we are getting 10 solutions. So whichever method you remember, you can perform that at the exam. So thank you. We meet again. for the next one.